Welcome everyone. Today we will present the EA block scheduling project. We will introduce our project in 4 parts: goal, system structure, analysis, and contribution. Our primary clients are Texas A&M engineering academic students across 10 academies, with key stakeholders including Austin Community College and Texas A&M University. We are starting with the Austin A&M Academy and plan to expand the program to other academies in the future. The program is designed to support approximately 200 students per semester on average. Our primary goal is to develop a block scheduling program for math, science, and engineering courses, allowing students to be assigned to a block schedule based on data provided through spreadsheets. The system is built with a clean architecture, with login system, spreadsheet parser, database, block generator, schedule builder, and the schedule viewer. The database is the backbone of our system, storing uploaded Excel file information, course data such as time, location, prerequisites, and capacity, user data including roles and contact information, generated block schedule data, ensuring smooth integration and easy access. We also implemented Gmail-based single sign-on. Users can log in seamlessly through OAuth using the Ruby gem for secure authentication. This simplifies access while ensuring security and scalability. Admins can upload class spreadsheets via a dedicated interface. Files are parsed, stored in the database, and displayed with options to download or delete. The block generator automates schedule creation and is the core feature of our system. Admins can define typical class groupings and set specific block conditions. Our algorithm processes these inputs to automatically generate possible class blocks. This is the prototype of our block generator. Students can view available blocks, check prerequisites, and access detailed information such as start or end times, instructors, and room locations. If a block selection is invalid or unavailable, users receive alerts and warnings for guidance. The schedule viewer allows students to visualize their blocks in 15-minute intervals. Each block is interactive, letting users click for detailed class information. Next part is analysis. In Spring 1, we focused on project setup, including the database schema, landing page, and app deployment to Heroku. In Spring 2, we implemented key features like Excel upload system, single sign-on, and blocks generating conditions. Spring 3 we enhanced the block generator, incorporated prerequisites into scheduling, and refined the user interface. In Spring 4, we finalized the schedule generation algorithm, add the schedule viewer, and error handling for invalid block selections. Along the development process, we also learned a lot. First one is user stories. They focus on understanding the user's needs and motivations, enabling the development team to prioritize features that deliver maximum value to the end user. And during our development process, we accidentally lost some progress due to a revert. So we suggest everyone frequently save your progress on your own dev branch and make reverts more carefully. We also discovered some cons of TDD. Writing tests can take significant time, especially for complex scenarios. When user stories or requirements evolve, the existing tests may no longer be valid. These are some of our to-do, including responsive web design and UI refinement. These are our members: Aaron, Aditi, Chen-Yan, June, Mahima, Ryan, and William. Thank you for your time.
Howdy. My name is Aaron Jones, and I'm a member of the EA Block Schedule Generator project. It would be my pleasure to demonstrate to you what my team has created in the short time we had together. Let me start by saying that one of the bigger struggles we had as a group was in keeping the scope of our work to what we knew we could get done in the short time frame we had. With that in mind, our app has plenty of room for expansion. Our focus was kept mainly to the functions our sponsor was responsible for. We expect that another group will pick up where we left off and polish up the admin features and implement the student features. With that being said, let's begin our demonstration by going over the admin features we were able to implement in our 4 sprints. As you can see from the landing page, our application is intended for our sponsor and students of Texas A&M's engineering academies. We decided to use Google's authentication features because most educational institutions use Gmail to communicate with and identify its students. All Texas A&M students, as well as Austin Community College's students, have a Gmail account they can use to log into the block schedule generator. Here's the landing page for an admin. Here is the first example of an area we expect our app to be improved. Application settings can be added to the back end, and one of those settings shown here could be an application-wide message the admin would be able to update whenever needed. The first tab in the admin navbar gives access to view all users of the system. Each user can be edited or removed by the admin. The owner of the system can use the selection options at the bottom of the user form to change a user's access rights. Next is the admin settings section. This is something that can be implemented in the future that, again, will allow the owner to update system settings and global messages. Now we move on to view the courses stored in the database. Each of these items, just like the user table, can be edited or destroyed by the system owner. Now we move on to the reason for our project. This is really where the block generation process starts. Our sponsor is given a spreadsheet of classes every semester that she uses to populate a Google form for her students. Those students use the form to pick a block of classes they would like to sign up for. In trying to automate this process, we implemented a service we will look at the end of the demo that parses an uploaded Excel spreadsheet and adds the courses on that sheet to the database. After all the courses have been added to the database and edited to include whatever the owner needs, like changing the course capacity, for example, the final part of the generation automation can be performed. This is done by admins in the blocks section of the application. Simply clicking the button to generate new blocks will have the system run through combinations of appropriate class choices and present them to the owner. Again, future teams will be able to focus on student features more specifically. We wanted to ensure our sponsors' tasks, which were described to our team as tedious and time-consuming, were automated first. These student sections really are placeholders for the time being. I know I enjoyed working on this project with my group. I hope we've exceeded our sponsors' expectations. I know for sure that we have created a solid system with many areas for new creative solutions. The possibilities are wide open. My hope is that our system turns into something amazing that our sponsor can brag about to future Aggie engineers and let them know their system was designed and created by Aggie engineers themselves.